So if you did it with the heats of formation, okay, the value you would get, okay, if you did it from the heats of formation, you would get negative 1427 or about, actually, negative 1428 kilojoules is what you get per mole of ethane. So you can see they're pretty close. Right? Negative 1428, negative 1406, they're pretty close. Which one is more trustworthy? Which one would you rather use? Would you use the heats of formation one, or would you use the bond energies one? You would want to use the heats of formation one. Because the heats of formation are from the compounds specific to water, CO2, O2, and ethane. Okay, whereas, remember the bond energies are just averaged bond energies from a whole, collection of molecules. Okay, they're not specific to ethane, they're not specific to water per se. Okay. Why would you ever want to use bond energies then? Like if this is less accurate, why would you ever use it? Well, because sometimes the heats of formation just haven't been measured for certain compounds. And so sometimes you have to just estimate what an enthalpy would be based on what the average bond energies would be. Right. Sometimes we don't have heats of formation for everything. We haven't done calorimetry on every compound there is. Okay. So that'd be a good test question, right? Why is the heats of formation more trustworthy? Okay. Because not every compound has had its heats of formation measured. Okay, so when that happens, we can go to the bond energies and say, well, I may not know exactly what the bond energies are, but we know at least on average what a certain bond type would be in energy. Okay, and we can estimate an enthalpy reaction from that. Right? We don't know that OH specifically in water has this bond energy of 464. We don't know that. Okay, but what we do know that is on average, over thousands of different compounds, the bond energy for OH is this, on average. All right, we don't know that the CH bond in ethane is 414 kilojoules per mole. Okay, we don't know that specifically for ethane. Right, the CH bond in ethane probably is a little bit different from this. Maybe not by a lot, but it's a little bit different. Okay, the CC bond in ethane, right, it might not be specifically 347, but it's on average across thousands of compounds, this is what we get. Okay, so this is why we use bond energies in order to estimate enthalpies of reaction when we do not have the heats of formation specific to those compounds. Am I making any sense whatsoever? Okay. It just nod, make me feel better about myself, even when I'm not really making any sense. Okay, so we can do the propane example in problem solving later. Okay, but that concludes chapter 9. All right, and we are going to start chapter 10. Does anybody still need lecture notes? I must have run out of
yeah, so your index finger has to be on like no, and then the other one has like these are the tops, and then this is the bottom, rest of the bottom.
Okay, so